Hello folks, today we're going to explain speed. Now what speed is the total distance an object goes in the certain amount of time. Now to calculate speed, you do the total distance it does go divided by its total time. To measure this, to measure speed, you do meters per second is how far it travels. For distance, it depends on what you're using. Usually it's in meters, but today it will be in centimeters, as centimeters are what we are using. Time is calculated in seconds. Now, for our example, we are going to get this timer out and time this car as it travels past this yardstick. Ready and go. Okay, so this car went about 90 centimeters in 1 second. In 1 second. Now, we're going to do the math up here on this board. It went, in 1 second, it went 90 centimeters. Okay, so 1 goes into 9 times, because 9 times 1 is 9. That makes this 9 minus 9 is 0. You drop your 0, 1 divided by 0 is 0. And so your answer is 90 meters per second is how fast that car is going. All right, to give you, and some things that affect speed are the total distance the object has to go, the total time, if there's any objects, like say this car, and the mass of the object, and the object blocking it. To explain this, we're going to give you a little visual of what would happen. Okay, let's just say you drive along, and all of a sudden, this guy falls asleep at the wheel for some reason, but instead of swerving, and he's all swerving crazy like this, and then next thing you know, he has this dead straight look, and he goes, well, you're just driving, and then he just puts his foot on the gas, and it crashes, an explosion. The whole window shattered. You're crying, what the heck's going on? The hospital won't get there for another hour. There's a guy in the passenger seat with a totaled arm, and there's all this type of screaming all over the place. There's a fire, the car's gas is leaking. Next thing you know, car explodes, you go flying, and all because that car and its passenger fell asleep, and it had the greater mass, then greater speed than this car.
Motion. Oh.
Okay, this is an example of Newton's first law of motion, which means that any object will stay in motion unless acted upon, which means if you put like this ball here, that's what stops Stelk here. If he would have kept going, he wouldn't have stopped till something like this happened. But then again, the same thing applies for an object without motion, will not move unless acted upon. Basically inertia, so if you don't move it, then it won't move, but if you do move it, then it will move. Kind of like this. There, see, he moved. And so now we'll explain Newton's third law. Wait, come back, come on. Hey, come back. That's an example of Newton's third law, which basically says for every action, there's an equal and opposite reaction. So even though Stelk there looks a little bigger than me, and I'm a little taller than Stelk, we both collided, so we both fell over. And there you have it, folks. Okay, so now we're going to explain the second law of Newton's laws. Oh, hey, nice, look at this. It's already written down for us on this handy dandy board. Okay, so what this means is acceleration, which is in meters per second squared, but is seen as A as the problem, is equal to the net force, or the total force applied here. And force has directions, so if it's this force north, that means you're going up, or south, west, east, and then that net force is divided by our mass, which is measured in kilograms. So like this. So the acceleration is equal to 6 newtons south divided by 12 kilograms. And what that equals, this equals 0.5 meters per second squared. And that is your acceleration right there. Yes?
Isn't it south?
Oh, yes, but it is also, due to the newtons, it is 5 meters per second south. Okay, and there is your equation for Newton's second law.